Let's talk about finding the sine and cosine of angles using the unit circle. The unit circle, pictured here, is a circle that has a radius of 1. The distance from the origin to any point on the circle is 1 unit. And this makes it easy to find the sine and cosine for angles on the unit circle. Because for every angle on the unit circle, the sine is just the associated y-coordinate. The sine of 30 degrees would just be 1/2. And that's because the sine ratio is y over r. And on the unit circle, since the radius is 1, the sine is just the y-coordinate. So for angles that are on the unit circle, finding the sine of those angles is very simple. Likewise, the cosine is just the x-coordinate. The cosine of 30 degrees would be the square root of 3 over 2. Again, because the cosine ratio is x over r, and r is 1 on this unit circle, the cosine is just the x-coordinate. Let's quickly discuss 5 examples of finding sines and cosines around the unit circle. Number 1, the sine of 135 degrees. Sine of 135 degrees. Remember, the sine is the associated y-coordinate with 135 degrees. The y-coordinate associated with 135 degrees is the square root of 2 over 2. The sine of 135 degrees is exactly the square root of 2 over 2. This is an irrational number, but it can be represented exactly with root 2 over 2. Number 2, let's take a look at an angle that's measured in radians. You can see on this unit circle, for each angle, there's a degree measure and a radian measure. The cosine of 4 pi over 3 will be the x-coordinate. Remember, cosine of any angle is the x-coordinate over the distance from the origin to a point on the terminal side of that angle. And on the unit circle, that distance is always 1. So the cosine of any angle on the unit circle is just the x-coordinate. 4 pi over 3 radians is this angle. 4 pi over 3 radians is represented by this angle. The x-coordinate, -1/2. For problem 3, let's try a negative angle. Let's evaluate the cosine of -30 degrees. Well, positive 30 degrees is this angle. -30 degrees is this angle. For an angle in standard position, a positive 30-degree angle is the same distance up and around the unit circle counterclockwise as -30 degrees is down and around the unit circle clockwise. The cosine is the associated x-coordinate with the -30-degree angle. Well, the associated ordered pair is right here, and that associated x-coordinate is the square root of 3 over 2. The cosine of -30 degrees is the square root of 3 over 2. How about the sine of pi? How about the sine of an angle measuring pi radians? An angle measuring pi radians on the unit circle is this one. The sine of pi is the associated y-coordinate with that angle, and that associated y-coordinate is 0. The sine of pi is 0. And finally, let's take a look at one more negative angle, a negative angle measured in radians, the sine of 2 pi over 3. Well, positive 2 pi over 3 is this angle. It goes up and around the unit circle counterclockwise, pi over 2 or 90 degrees, and then pi over 6 or 30 degrees more. Let's go that same distance down and clockwise to find -2 pi over 3. It's in standard position. We'll start at the x-axis and go down and around clockwise. The same distance. This angle, the angle that I've outlined in red, is -2 pi over 3. The sine of this angle would be the associated y-coordinate, which in this case is -square root of 3 over 2. The sine of -2 pi over 3 radians is -square root of 3 over 2.